Hey guys, it's Vince from Keystone Metal. I've been professionally welding for about 12 years now, and today we're going to do a video on intro to TIG welding. TIG welding stands for tungsten inert gas, otherwise known as GTAL, which is gas tungsten arc welding. Basically, in a nutshell, what it is you're using a torch and a filler rod to create your weld. Your torch is going to consist of an electrode, which is going to puncture your material with heat. As you create your puddle, you're going to add your filler rod, and that's how you're going to create your bead. All right, so here we have our basic TIG torch. I'm going to break down the components for you guys. We'll go tip to butt here. We'll start in the front. Out front we have our nozzle here. This is going to be offered to you guys in different sizes, different materials. Some are better than others for shielding gas purposes. So the number that correlates on the side of this could be 6, 7, 8, goes all the way up to 14, even larger on some applications. This is your orifice diameter that's going to change by the number. The larger the number, the larger the hole. Moving back even farther, the next thing we have our tungsten. So today we have pink tungsten in here, which is also multi-mix. This is a very broad tungsten, so for guys who are beginning, you can pick this tungsten up and this is going to cover most of your needs in your garage. You really don't have to worry about diving into the specifics of all the different tungstens. If you do want to, there are other tungstens that are specific for certain materials. There's definitely value added in that, but to keep things easy, to keep things for beginners, you guys can just pick up these multi-mix tungsten and you're pretty much good to weld aluminum, steel, and you can even weld stainless with it. Moving back from there, we have our diffuser up next, or a gas lens. This is actually a gas lens, so this is kind of a newer style. This helps a little bit with shielding gas dispersion. The older style of this would just be called a diffuser. It's a little bit less efficient, we'll say, when it comes to covering your puddle with the correct amount of shielding gas. Inside of that, you have what is your collet body. So this is what holds your tungsten in place. Basically inside the torch, this is what it's going to look like. Your tungsten slides through your collet body like this, and then when you slide it in here, your back cap, which is your last piece, as you tighten this down, it tightens down your collet body, which in turn holds your tungsten in place and stops it from adjusting back and forth while you're welding. This back cap comes in different sizes as well. You can get short, medium, stubbies, longs. They all have an O-ring here to seal the back of the torch, so you won't be losing your shielding gas out of the back. Moving down the torch here, sometimes you have a flex head torch, so you'll be able to aid yourself in various positions that are more difficult to reach with a standard torch that doesn't flex. Inside the torch, you're going to have your power cables. If your torch is water cooled, you'll have your internals for cooling inside as well. We also have a torch controller on this one. This is an alternate to your pedal feed. So instead of using a pedal, if you're doing a roll cage or something underneath of a dashboard, this is going to make your life easy. You kind of just get up under there, use this to control your heat input, and cut it, and that's it. Other than that, this runs to the back of the machine. Pretty basic setup. All right, so we discussed a little bit about the different types of tungsten, but there's also different sizes of tungsten available. On the table here, we have 1/16 and 3/32. These are basically different sizes for different projects. The material thickness that you're working on should kind of dictate what size tungsten you grab, the amount of input of heat that you're putting into it. The last thing you want to do is fray or ball your tungsten up because you're putting too much heat into the material itself, the tungsten material itself. If you're welding thin gauge stuff, 22 gauge, 20 gauge, 16th is it's gonna work well for you. Once you start getting into the thicker stuff, 16th, 1/8, I would recommend switching to the 3/32, the thicker tungsten to hold a heavier heat load. You can go up to 1/8" tungsten. And again, this is basically just a reference to your material size. So the thicker the material, the more heat that you need to input to weld, the thicker the tungsten that you're gonna want to handle the job. All right, so we have a few different gas lens and diffuser setups here. We'll discuss the difference between these real quick. So on the right here, you have your standard, what most of your TIG setups are gonna come with. So this is a standard diffuser here, and as you can see, the way that this is set up is it has 4 holes that are ported in around the head of this diffuser. As your shielding gas travels up the diffuser, it comes out the sides, and then it'll come up the nozzle and out of the nozzle. So it's kind of, we'll call it ambiguous, the way that the gas travels around. And then as we move over to what we call the newer style, or the more precision style of gas lens, as you can see, this has a lens directly at the top, and all the gases will travel straight up and straight out. When you insert this into the nozzle, it helps everything become streamed straight out of the nozzle, hits your material, and disperses evenly on both sides of the puddle that you're welding. The shorter version of this right here, and you'll notice it's a Pyrex cup. there's a couple benefits to this. So these are typically what you're gonna see when you go to increase your orifice size. Anything over like an 8 or a 9, you'll typically get into a Pyrex cup where you'll see 10s, 12s, 14s, 16s, very large orifices here. And this is just a stubby version of this to accommodate this new cup here. So a second pro of having a clear nozzle is that you can actually see through them while you're welding. It's one of the benefits of welding in tight spaces, or if you're pretty confined and you don't have much wrist movement, you can see through the Pyrex cup and see what you're doing versus trying to look through something that's solid ceramic like this. It doesn't really work as well. So again, any of these are gonna work for you. You're always gonna get better results with a gas lens versus your standard diffuser, in my opinion. And then this is more for a comfort. And another good thing about the Eastwood kit is that it already comes with this gas lens here, so you typically won't have to concern yourself running the older style stuff here. All right, guys, so we talked about the different kinds of tungstens and the different sizes of tungstens, and it's basically the same concept when you switch over to filler rod. So we have different materials, different sizes. Real quick, we'll discuss what would be used where. So we have common sizes, 030, 035, 045, 1/16, 3/32, 1/8, they're all stuff that you guys are gonna see. We have different types. This is currently ER70S, so this is a good fill rod for carbon steel, mild steel. Other stuff that you guys would probably use, 316 and 304 is good for just stainless. A 309L would be good for dissimilar metals, joining stainless to carbon. 4043 or something along those lines is good for aluminum. And then when you select the size that you want to use to the material, what I like to recommend to people is that you don't want a thick filler rod, because what ends up happening is you have to heat your fill rod to create your puddle. So the last thing you want to do is have to put so much heat input into your material that you're burning away your base metal just trying to get your fill rod to melt. So my general rule of thumb is that I always like to stage down my fill rod at least 1 or 2 sizes from my material. If I'm welding 1/8 inch material, I'll approach it with 1/16. If I'm welding 1/16 material, I'll approach it with an 045 or something like that. Again, if you're doing sheet metal work, like 023, 030 work, you're gonna wanna stick to like 035 fill rod, the thinnest stuff that you can find. If you're really in a pinch and you need something super, super thin, not typically something I like to recommend, but if you guys have really thin MIG wire on a spool, you can always clean that up real quick and use that as a fill too, that'll aid you. So that's a brief overview of the different types of filler rod, the different sizes, and when you guys would apply them. All right, so here we have our 2 different types of controls for your heat input. The first one here on my left is your torch controller, and then we have a foot pedal here. This is your basic style rocker foot pedal. As you increase this, it's similar to the gas pedal on your vehicle. The farther down you go, the more heat input it applies to the material, as long as your machine is set up correctly. So to touch base on when I would select either of these, this one on the left is typically used for tighter spaces. If you're doing roll cages on cars, if you're even sometimes if you're doing an exhaust or something like that and you have to get into a weird spot, this is good because you can kind of just get up there, hit your control, and then back off when you're done. The con to the torch controller, in my opinion, is that this style, where you have a clicker switch here, it's on or off. So when you set your amperage, say you have your amperage set to 85, as soon as you hit this, you're getting 85 amps. And when you're done with it, you hit it again and it'll cut your 85 amps. Switching to the pedal, you set your machine to 85 amps. Again, it's like your car, it's a pedal. You don't have to go 85 amps with it. You can just rock into it. You can do 30 amps, 40 amps, and then full throttle would give you your 85, but it allows you to have that control. Now, they do make some torch controllers that have rollers on them, which will allow you to do the same thing. As you roll it, you'll increase your heat. As you roll back, you'll decrease your heat. This specific setup that comes with the Eastwood machine, this is just a click style, which is great for certain things. Just make sure that you're keeping your amperage low as to not burn through and essentially ruin the part that you're trying to weld. Pros to the foot pedal, again, it's pretty comfortable when you're working at a bench or something like that, and you're already in this sitting stance. It's very comfortable to use a foot pedal. However, what I would recommend about this is it's also difficult to use, and sometimes you'll find yourself in a shop environment or something where you're on a positioner and you have to control the speed of the turntable with one foot. You don't want to be controlling 2 pedals at the same time. So it's good to switch back to something like this. You can use your foot to control the turn of your positioner and just use this to activate and deactivate your arc. So those are your 2 styles. Both of these come with the Eastwood machine, and they're both pretty much guaranteed to get you through whatever job you're up against. This Eastwood TIG 200 AC/DC, this is a good beginner welder, strictly for the fact that it's simple. It's not overwhelming. Some of these other welders that you're gonna see out there, they have a lot of adjustability, a lot of settings, and it can overwhelm a new user. This specific welder right here keeps it very simple, very straightforward for you guys, and it's kind of geared to get you going quick. So the first thing we're gonna go over is the switch for your foot pedal or your panel control. Again, it's pretty basic. You're either using your foot pedal or you wanna switch to your torch controller. Depending on the project that you wanna use, depending on which approach you wanna take, that's the selection that you're gonna make right there. So the button below that, it's gonna be your switch for AC/DC. DC stands for direct current, AC alternating current. Your DC is typically gonna be used for all your stainless and carbons, and then you'll switch to AC for aluminum. The next switch that we have is alternation between TIG and stick. These inverter style welders are going to give you the capability to do either a TIG or a stick approach to your project. So depending on what you're doing, if you wanted to switch to a stick setup, install all your stick components and then you're good to go. So the first knob that we have is your amp knob. This is going to control your heat input. If you have it dialed all the way down, the lower the number, the less heat that you're going to put into your material. The higher the number, the more heat that you're going to put into your material. So the next knob here is clearance. It's also known as your balance effect. It's used for mostly AC welding when we're doing aluminum, not stuff that we're gonna touch on today, but it is there if you need it. All right, so the two controls at the bottom, one's for pre-flow and one is for post-flow, and it is just that. So as you hit your pedal and you initiate your weld, you're gonna get pre-flow, which is shielding gas that comes out of the torch prior to the arc. So in situations where you need to purge your material, sometimes it's good to shield your material before you light up on it to eliminate the option of any oxygen entering your puddle before you start to weld. The other setting is post-flow. It's the exact opposite. It's the amount of flow that continues to come out of the torch after you terminate your arc. This is important for cooling effects. Immediately, if you have a weld that's you just finished, you terminate your weld, the last thing you want to do is pull your torch away right away and let all the oxygen rush to the weld. So by keeping your post-flow setting, you'll eliminate your arc, you'll keep your torch over your weld in the same spot, and you'll allow it to flood that bead with more shielding gas. The amount of time that you have set to your post-flow and your pre-flow is determined by the project that you're doing, the thickness of the material, how long the weld was, the size of the nozzle that you're using. A lot of different things go into that. In a basic overview, pre and post-flow is just the amount of flow of shielding gas coming out of the torch prior and post your weld. And so with these Eastwood machines here, you're gonna find a reference chart that's gonna help you out with all your settings and your consumables as well. You can reference that chart to help you guys get started. All right, and the last thing before welding, while you're setting up your machine, is you wanna make sure that your table is grounded or your welder is grounded. This is a metal table, so we can ground right to the table. If for whatever reason you don't have a connection straight to metal to your part, you can always ground directly to the part. I think the closer the ground is to the part you're welding on, the better results. But again, if you're all metal, metal on metal, touching everything, you should be good. Take your ground from your machine, ground it right to your table, and you're good to start welding. So to touch base on shielding gas real quick and what it is, shielding gas is the gas that's going to come out of your torch while you're welding. It's going to cover your weld and it's going to prevent oxygen from entering your weld, which will cause porosity into your bead. Shielding gas on a TIG machine is different than shielding gas on a MIG machine. MIG machine, you're going to find multiple different ranges. You can have dual mixes, tri-mixes. You can do a flux core version on that where there is no gas. TIG welding, different. You always need shielding gas. There is no flux core version, we'll call it, of TIG welding. So it's very important you guys always have a shielding gas. Typically you're going to see 100% argon when it comes to TIG, but there are certain applications where people will introduce helium as well. But we want to stress the importance of shielding gas when you're TIG welding on any TIG machine that you're picking up. All right, so to set your flow up, your cubic feet per hour CFH, what you're going to do here is you're going to plug your welder in, turn it on, you're going to plug your pedal in, you're going to hit your pedal, and on the flow meter here, you're going to watch where your ball lands on the argon chart. So we want to be anywhere between 15 and 35 typically. That's going to be your range for aluminum all the way up to stainless and other exotic metals. So when I hit my pedal, I'm floating it, and then I can adjust it open and close with this knob here. For today, I wanted to run this at about 30, so I'll sit it right there at 30. I know I'm good on my flow, let off my pedal, and I'm good to go. My meter on the right here, this is my regulator. This is going to indicate how much gas is actually left in my bottle, and this one here on my left is the flow meter. This is going to regulate my real-time shielding gas flow while I'm welding. All right, so now we're gonna talk about some PPE, personal protective equipment, just your typical safety gear while you're welding. You can obtain a lot of injuries and irritable things to deal with from welding if you don't approach the job correctly. So the first thing we'll talk about is wearing a jacket, long sleeves, something to protect you from the UV light that's emitted from the torch. You can sunburn yourself very easily. You can torch your skin up, you'll be red for days, blister up, it gets pretty bad. The second thing we'll move on to is a proper helmet. Not only having a proper helmet, but making sure your shade inside is properly adjusted correctly for what you're welding is very important as well. You can sustain damage to your vision by not having your helmet adjusted properly. So when you guys are in the market for a helmet, I always recommend for beginners to grab an auto darkener, something that has a shade up to at least 13. It's gonna eliminate the thought process for you guys. Flip your hood down, light up, the helmet does all the work for you. Next up, we have different sets of gloves here, different thicknesses. They're gonna offer different dexterity and different protection as far as welding. So the thicker set here, typically you'll see guys using these for cutting or MIG welding or stick welding, something that produces a lot more heat and spatter as well. As you move over towards the more precision type welding, you want something a little bit thinner, something that has more dexterity so that you can feel the wire, feel the torch, feel what you're doing a little bit better. In a pinch, garage gloves, they'll get you through. After that, we recommend that you use a respirator for certain materials. Some people will say that, you know, TIG welding is the least toxic of all. However, sometimes you're gonna get material that has been coated in oil, or a certain part of it has oil or paint on it, and the toxins they'll get you when they burn off if you heat them up correctly. Hearing protection and eye protection, there are two things that are used as discretion when it comes to TIG welding. If you're typically doing aluminum work or AC, alternating current work, the machine can make some pretty wildly noises. So maybe you want to put some hearing protection in to avoid getting a headache from that or something. As far as eye protection goes, always good to use in the shop. Some people like to wear it underneath of their helmet. Typically not something that I would do, but it is an option for you. We want to talk about your electrode and sharpening tungsten and why it's important to keep a good point on your electrode here. On the left here, you're going to see that we have two different angles, but they're both sharpened correctly and ready for work. And on the right here, you're going to see we have various types of destroyed tungsten, we'll call it. So the importance of keeping a good point on your tungsten is your electrode control, your heat control. So when you light up with a very sharpened point on your tungsten, you get an arc that's very controllable. It's pinpointed into one spot. It helps you control your bead very easily. If you run into a couple scenarios that will cause your tungsten to ball up or distort itself, what's going to end up happening is your arc is going to start to wander around your part. So instead of having a controlled heat input, your heat input's going to walk all over the place, and then when you try to add your filler wire, you're not going to get a very consistent result. Your beads aren't going to look like dimes, they're going to look like puddles that are just slapped together, and it doesn't look very pretty. So let's real quick talk about how we end up with a tungsten that looks like this. There's several different things that can happen. The first thing and the most common thing that I see is while you're welding, you accidentally dip your tungsten into the puddle. What ends up happening here is you get a bunch of extra material, whatever the material is that you're welding, stuck to the tungsten, and then again, your arc is wandering all over the place. It's very hard for you to keep a good heat control and a good consistent bead. The other thing that can happen, which is even worse, especially if you're not wearing your safety gear like your gloves, is you will touch your tungsten to your fill rod, and then you'll probably electrocute yourself, which is not fun. You'll zap yourself, your elbows tingle for a while. It's not enjoyable for anybody. The next thing we'll talk about is how to sharpen it and what the best methods are. There's usually three methods that I see people use. The first one is using a pedestal grinder, where they will grind their point on a stone. The second one is they'll insert their tungsten into a drill and they'll bring it over to a belt sander and they'll put their point on it that way. And then the third way, and the most efficient way that I found, is to use a tungsten grinder like this one from Eastwood. So this one is going to offer you different options for 1/16 and 3/32 tungsten, and it's also going to offer you different angles of 10 and 22.5 degrees. This makes sharpening your tungsten very easy. And it also eliminates, if you guys are into the world of production, it eliminates the waste of time having to get up, travel across the shop, whatever you have to do to sharpen your tungsten. Keep one of these, plug it in, or on the new ones that are wireless, you can just keep them on your bench, and then you don't even have to get up. You can just remove your electrode from your torch, sharpen it up, get right back to work. All right, so we talked about tungsten already. One thing we didn't touch on was the stick out of the electrode. So when you're running a pretty basic setup, typically what I recommend is running your tungsten, the stick out, just to the base of where you have it sharpened. If you switch over to a gas lens where you can achieve greater shielding gas, Feel free to pull your tungsten out. You can run 3/8, maybe ½ an inch out, and still get the proper gas coverage that you need. So for today, since we're just doing a butt joint, I can get away with running a shorter stick out. In the future, if you guys approach a T-joint or something and you need to create a little bit of stick out so your nozzle's not hitting the material before you hit the joint, that's another option for you as well. All right, so the next portion we're going to talk about metal prep and how to clean your metal before you approach the welding process. Different materials are obviously going to require different levels of cleaning before you start your welding process. This specific material here is mild steel. One thing to look at when you're working with mild steel is to make sure that there's no oxidation that has occurred on the surface level of it. This piece looks pretty good. There's a small spot right there. One thing that you can do to remove oxidation, you can use sanders, you can use roll-lock wheels on die grinders, stuff like that. You can use metal brushes. Depending on the severity of it, the overall goal is to get the material down to raw metal before you approach trying to weld it at all. So for this stuff right here, it's already pretty clean. There's one small spot of oxidation right here, so I'll show you. You can take a wire brush, kind of grind it. I always like to push in the same direction when I'm grinding instead of going back and forth. I always like to go in the same direction. Kind of helps brush anything out instead of brushing anything into the material itself. So we'll brush this out. And then as soon as you get done brushing or sanding or whatever you guys are doing to prep your material, you always want to make sure that you're wiping it down with acetone or something. Give you a little bit there on your rag and then just wipe down your material. Make sure it's clean and free of any debris, lubricants, oils, or anything like that before you start your welding process. And then another note, after you guys wipe down your stuff with acetone, it's very important. This stuff is very flammable. Get it off your table, get it out of the working station, especially if you're working with MIG and you're sending spatter. It'll light this rag up, it'll catch on fire. If you guys have it in a cup, that cup will light up, and it's a vapor fire, so the only way to suffocate this, or the only way to put it out, is to suffocate it. You guys can't spread water on it. You can't dump it all over the place. It'll just spread all over the place, so be conscious about where your location is of your acetone and any rags that are soaked in it while you're welding. Get them away from your workspace. So the next thing we want to touch base on is the theory of ABC, which is always be comfortable. I'm a pretty strong advocate of this when it comes to welding. I think the more comfortable you are and the better you can see, the better results you're always going to get. So two things that I like to touch on with people is make sure you get a good helmet that allows you to see properly, and then make sure you get yourself in a good position that allows you to be comfortable throughout the duration of your weld. Obviously, there are some situations and circumstances where you're not going to be comfortable. It's kind of impossible. You're crammed into tight, confined spaces. You have to work with it. But when we can set up to make sure that we can be comfortable, we try to do everything that we can to make sure that we're getting the best results possible. So some things to consider when you're getting yourself comfortable is pedal positioning. You don't want it pushed too far under the table. You don't want it too far away from your chair. Next thing, speaking of chair, is your chair height in relation to your table or your workspace. You don't want to be too tall or sitting too low. And then the other thing that's pretty important is positioning your material itself. So if you need to use clamps, if you need to use magnets on some stuff to keep it square or flush, if you need to use vice grips or table vices, whatever works for you guys, to keep the material from rolling or moving or adjusting while you're welding, it's going to help you get a better result in your end product. All right, so one thing to consider when getting comfortable is going to be your torch, actually, what to do with the cord, how to hold it, how to maneuver it. One thing that I like to touch base on is if you are in a position where you can be comfortable seated at a bench, I like to hold this the way that I would hold a paintbrush, a pencil, a pen, anything that's going to give me control over the front end of the torch. I've noticed if you hold the torch back here lower, the front of the torch gets a little wobbly. It's hard to control the stability of the front, moves back and forth, doesn't really give you good results. There are some situations in pipe welding or walking the cup where you'll switch your grip from a pencil down here like this, almost a screwdriver, and that'll allow you to give you the wrist movement that you need. Whenever you're welding something that's round or something, you might want to switch to this position as well. It'll give you the ability to roll the torch versus trying to roll the torch with a weird wrist. And then, of course, the cord and the weight of the cord. This can be pretty difficult, and it could also get snagged up on things, which is pretty annoying. When you're sitting at a table, sometimes the cord will get snagged on the corner of the bench, and then when you go to move, you'll feel resistance in your torch, and you won't be able to push any farther. To unload the weight of the cord, you can drape it around you. You can drape it over your lap here and take the weight off of it. You can drape it around your back, take the weight off of it like that. However you guys approach it, I've just noticed that when you let the torch hang like this, you're constantly holding the weight up and you're fighting the drip back here, which is the annoying part. So if you can take the weight off of this, the torch will move freely and allow you guys to get a better result. All right, so to piggyback off of comfort, guys, we'll talk about how to hold your torch, how to hold your filler wire, what's gonna be comfortable for you. If you're a right-handed welder, you're gonna hold your torch in your right hand, your fill rod in your left hand. If you're a left-handed welder, you'll reverse that. When you hold your torch approach to your weld joint, you wanna make sure that you're comfortable with your hand, and you wanna make sure that you're not cutting off or restricting any shielding gas. So typically, you wanna be straight down like this. When your shielding gas exits your nozzle here, you want it to hit your material and flood both sides of the weld. If I have my torch angled this way or this way, however it may be, as I weld, I'm gonna cover my first inch here, but then as soon as my shielding gas gets past my weld in the back here, I'm cutting off everything in the back from receiving any more shielding gas. I can eliminate this by simply rotating my torch this way so that when my shielding gas hits my material, instead of hitting and being pushed forward, it hits and disperses back and forth evenly. This is gonna give you good control. It'll give you good flow of your shielding gas over your puddle throughout. The most important thing here is to make sure that you're not rotating the wrist to push and you're sliding your arm on your material to keep your nozzle straight down the whole time. If there's a situation where you guys can't keep it straight or it's just not comfortable to and you do have to tilt it, I try to tell people to avoid breaching that 45-degree angle. Once you get to that point, you're kind of pushing your shielding gas in a direction that's not so great. So if you can keep it around 15, maybe 30 degrees, somewhere around there, if you do have to angle it, and then just keep yourself comfortable so you can see what you're doing. But the most important thing is that we're covering our bead with proper shielding gas during the whole weld. We want to talk about distance from your electrode to your material right now. It's important that you guys aren't getting too close, and it's also important that you're not getting too far away. So what I typically like to do is I like to get my tungsten as close to the material as I possibly can without running the risk of hitting my electrode with my filler rod as I'm dabbing. So one thing that's important to note is the angle that you're feeding your filler rod. And the second thing that I like to touch on that most people don't consider is the length of your fill rod. So as I'm trying to fill here, you'll notice that if I keep my fill rod the full length, the back of it likes to dance a little bit and it affects the front end. So a simple fix to this is to just trim it in half. The shorter the fill rod is, the more rigid it becomes. So when you have it like this, it eliminates the bounce in the back and it allows you to control it in the front a little bit more. The way that we're gonna do this is you'll get as close as you can to the material without jeopardizing this. Something that I like to do is kind of see if I can slide my rod underneath of my electrode. If I can do this, I'm usually in a pretty safe zone. The other thing I want to touch base on is as you're feeding, it's important that you're not leaving your fill rod too close to your puddle. You'll melt the fill rod. It'll kind of just make a mess of things and it doesn't keep it clean. So it's important that as you're making your dabs with your fill rod, you're removing it completely from the weld puddle before you re-enter. So one thing that can be difficult is understanding how to feed the wire consistently to make sure that your beads are consistent. Sometimes a lot of people, they'll just hold the wire in one spot and they'll kind of dab it until they get the result that they want. The problem with this is that the fill rod, will eventually get shorter and shorter to the point where your fingers are so close to the puddle that now you're kind of burning your gloves, burning your hand a little bit when you're trying to feed. So in order to eliminate this, one technique that I like to tell people a lot is insert the fill rod between your middle finger and your index finger on your feed hand. And then as the rod sits into the webbing of your thumb, all you're gonna do is squeeze it and push it forward. This movement is gonna give you a consistent bead feed every single time. You can do a half a feed, you can do a full feed, however it is, but what I like to recommend people is take a piece of filler rod, even when you're sitting there watching TV, whatever you're doing, driving, whatever it may be, and just sit here and feed it back and forth. This is gonna get you used to being consistent with how much rod you're feeding into your puddle on each bead. Just simply talking about starting your arc, what we wanna do is we're gonna get it as close as we can. We've already identified our distance of how far away from our material we wanna be. As we hit our pedal, we're gonna keep our fill rod clean and we're gonna increase our heat with our pedal until we see this material turn into liquid. You wanna keep a small puddle. You don't want it to be out of control. You don't want it to look like a pool right away. Just a very small bead of liquid is all you want, and then you wanna introduce heat slowly until you have a comfortable bead size. Once you have a liquid puddle formed, all you're gonna be doing is filling your rod. You're just gonna dab it in until you have a bead, and then you're gonna start moving forward while dabbing more material in to create beads that look like the effect of stacked dimes. All right, so now that we gave you guys the basics of how to set everything up and get started on welding, we're actually gonna get started with a fusion weld, which is basically just a weld without adding filler wire. We're gonna do this just to show you guys the base movements of the torch before we introduce the wire to it. All right guys, so I'm arcing up on the material. I'm waiting until I see I have a puddle established. Once I have a puddle there, I can start to move forward. The beginner's way to do this is to move forward, establish a puddle, dab your filler rod here, and then move forward, establish a puddle, dab your filler rod, move forward, establish your puddle, filler, move forward, filler, move forward, filler, move forward. All right, so this is an introduction way to do it. The other way, once you get this down, basically what you're gonna end up doing is just dragging your torch forward like this without pausing, and we'll be adding our filler rod simultaneously as we're doing this. All right, so that was fusion welding, or also known as autogenous welding, and now we're gonna move into the same process. We're just gonna add our filler rod. All right guys, the same concept here. I'm arcing up on the material. I'm waiting until I see I have a puddle. Once it's established, I'm gonna add my fill rod, and then I'm gonna move forward, add my fill rod, move forward, add fill rod. And we're just repeating this process until you basically get to the point where you're smooth enough where you no longer have to stop the torch and you can just keep moving. And as you can see, I'm just dabbing my fill rod right into the end of the puddle, and then I'm completely removing it from the torch's heat. And then when you terminate your weld, you're going to terminate slowly off your pedal so that there's no crater, and then you're going to hold your post flow there. All right guys, so we have our three welds, or three attempted welds next to each other here. This first one here over here on the right was obviously way too cold. We weren't even able to penetrate the metal, create a puddle at all. Right in front of that is our settings were too hot. A lot of indicators on this are how washy our puddles are. We have no consistency with that. It's a very flat weld. We burned through on the other side, so we got a lot of sugaring on the back side of the joint here. And then our HAZ, which is our heat affected zone, you can see how stretched out the heat is here. So all this stuff kind of plays into warping and part distortion. Obviously both of these parts distorted, but controlling that's something we can talk about in future videos. However, the one thing that obviously is a contributor of that is overheating. On the left here, we have the bead where our settings were controlled properly. We were able to penetrate the metal correctly. We were able to build a good consistent bead profile. And if we look on the back side, there's no sugaring on here. It's good penetration. And our HAZ area, as you can see, is it's very consistent throughout the whole thing. So these are the results that we're looking for, and these are two results that you guys can look for to identify incorrect settings, whether they be too hot or too cold. It's usually easy to tell right off the rip. All right guys, so those were some basics of introduction to TIG welding, and that's what's going to get you started. There's a lot of other things that we can go down. The rabbit hole gets pretty deep as far as titanium, aluminum, stainless, welding thin gauge sheet metal. There's a lot we can do here, but if you practice these basic concepts that you learned here today, this will get you into the world of TIG welding. It'll get you ready for a lot of projects, and it'll get you ready for the basic fundamentals that you can later develop into stronger skills to approach bigger and more intricate projects. And you can let us know in the comments below if there's anything you'd like to see us cover next, or if there's anything you think we didn't cover in this video. For more information on any of these products, you guys can check out eastwood.com.